Hey guys, welcome back. Houston Math Prep here. In this video, we're going to work through another example factoring a polynomial beginning by using the rational roots theorem. So the rational roots theorem says we can list out the possible rational roots in the form plus or minus p over q, where p is all the integer factors of 4, our constant term, and q is all the integer factors of our lead coefficient, in this case 1. So all the integer factors of 4 are plus and minus 1, 2, and 4, over all the integer factors of 1 are just 1. So that means we have 6 possible rational roots: positive and negative 1, positive and negative 2, and positive and negative 4. Once we've got our list, we can go ahead and start setting up for synthetic division. So I have 1x to the 4th. Notice here I'm missing x cubed, so I need to put that we have 0x cubed, negative 12x squared, negative 15x, and minus 4. Now, of course, you can test these in any order that you want. I'm going to go ahead and start with 1. I just like to go in numerical order. So let's see. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 12 plus 1 is negative 11. 1 times negative 11 is negative 11. Negative 15 plus negative 11 is negative 26. And 1 times negative 26 is negative 26. So I get a remainder of negative 30. That means that 1 is not a rational root of this g of x. So I'll go ahead now and set up to test negative 1. So I'm just copying down my same setup, but this time I'm going to test negative 1. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 12 plus 1 is negative 11. Negative 1 times negative 11 is positive 11. Negative 15 plus 11 is negative 4. And negative 1 times negative 4 is positive 4. So I get a remainder of 0. That tells me that g of x does have negative 1 as one of its roots. So I'll go ahead and start rewriting g of x. G of x can be written as x minus negative 1, or x plus 1, times whatever I have here. So here's my constant, my x squared, and my x cubed. So that's x cubed minus x squared minus 11x minus 4. Now we found one value that works, but we still have a cubic piece to our puzzle. And since we can't just factor this cubic, we need to continue testing values. But we don't have to keep testing them into the original set of coefficients. We can now just test to see if they work in this cubic. So if you go and keep on testing, you will find that the next one that works is positive 4. So let's see that work out. So 1, negative 1, I'm just bringing my coefficients here, negative 11 and negative 4. Bringing that one down, 4 times 1 is 4, negative 1 plus 4 is 3. 4 times 3 is 12, negative 11 plus 12 is 1. And 4 times 1 is 4, so with 4 we get a remainder of 0. That means we can come back here to g of x, keep our x plus 1 factor, bring in an x minus 4, and then write down what we have left. So here's our constant, our x, and our x squared. So we'll have x squared plus 3x plus 1. Now that we have this down to a quadratic, we can use our normal quadratic factoring methods to see if we can factor this. So we would be looking for values that multiply to give 1, but add to give 3. Well, the only way to get 1 is 1 times 1, which would add to be 2, or -1 times -1, which would add to be -2. So that means that this quadratic here does not factor, and that is g of x as factored as it can get. Alright guys, that does it for this video on factoring polynomials using the rational roots theorem. Until next time, we'll see you in a future video.